So this video is on objective 6.4 in topic 7, which is to explain the difference between competitive and non-competitive inhibition with reference to one example each. So I'll start with an animation about how enzymes work. Here. So enzymes are proteins that speed up chemical reactions in the cell, and the active site fits with specific substrate molecules. An enzyme works by binding to one or more specific molecules called reactants or substrates, and binding occurs at the active site. And they interact to perform an enzyme-substrate complex. And they form a different molecule because of the chemical reactions with the substrate complex, forming a new product, and the enzyme reforms after the catalyzation. So what a competitive inhibitor does is it inhibits the enzyme where the binding of the inhibitor to the active site on the enzyme prevents the binding of the substrate, and vice versa. So most competitive inhibitors function by binding reversibly to the active site of the enzyme. So pretty much competitive inhibition is when an inhibitor interacts with the active site on an enzyme and competes with the substrate because it's able to fit into the active site on the enzyme. And an example is malonic acid, which competes with succinate for active sites of succinic dehydrogenase, which is an important enzyme in the Krebs cycle. And non-competitive inhibition is a type of enzyme inhibition where the inhibitor reduces the activity of the enzyme and it binds equally well to the enzyme whether or not it has already bound to the substrate, or whether or not it has already bound the substrate. So pretty much non-competitive inhibition is when the inhibitor binds to an area of the enzyme that's not an active site and changes the shape of the active site. And an example is the amino acid alanine, which non-competitively inhibits the enzyme pyruvate kinase. And alanine is one product of a series of enzyme-catalyzed reactions, and the first step is catalyzed by pyruvate kinase. So this makes sense because alanine will be like an end product inhibitor. So if too much alanine is produced, then it inhibits the first enzyme, pyruvate kinase, which helps stop the enzyme catalyzed reaction if there's too much of the end product. So competitive and non-competitive inhibition are different mainly because of how competitive inhibition competes with the substrate by interacting with the active site, while non-competitive inhibition changes the overall shape of the active site, which is how their names are derived, and that's how you can remember it. So, yeah.